All right, so yesterday we spent time going over solids, liquids, and gas. We went over chemical and physical changes. I'll be printing off those while you're taking the miniature SchoolNet test and calling people up front to give you your gems in your Infinity Gauntlets. If you didn't bring that with you today, you can do it tomorrow. We're not going back to get those. But one thing that we haven't talked a whole lot about is parts of the whole. So we're going to spend a little bit of time talking about parts of the whole. Then we're going to look forward to one of these other things, more than likely heat exchange, and we'll talk about conduction, convection, and radiation, which again still blends into the water cycle. And I'm amazed at how many people are still struggling with the water cycle, even though I feel like that's all I've done this year is water cycle, water cycle, water cycle. But let's go through parts of the whole, and we'll go through this. We're not gonna fall into the misconceptions. If we do it today, that's fine, but we're not gonna do it next week. So again, remember when we took that small cup of Goldfish? Yeah, see, people remember this, and it's the same thing in the last class. We took a tiny cup of Goldfish, and I weighed it, and let's just say it weighed 5 ounces. And then we smushed those goldfish into teeny tiny little pieces. It is very easy for you to look at that and assume that it weighs less because, number one, it doesn't take up nearly as much space in the cup anymore. Not even close. And it's much smaller pieces. However, I have to ask this question. Emma, if I take those goldfish and I smush them all up in the cup, did I take any goldfish out? Did I remove any bits and pieces of the goldfish? Oddly enough, it weighed exactly the same thing, didn't it? Which was something that I think people weren't ready for. But all those teeny tiny little pieces are the teeny tiny little pieces that made up the whole goldfish that were in there before we smushed them to bits. We took Play-Doh and you rolled it into a ball. I think we did this in groups at that point. And we weighed the ball of Play-Doh. And let's just say the ball of Play-Doh weighed 5 ounces. Then I ask you to break that ball of Play-Doh up into the tiniest pieces that you could. And everybody in here was pinching little pieces off, and you're making little teeny tiny balls of Play-Doh. Remember doing that? Yes. And then we put all of that on the scale. Some of you said, whoa, Mr. Bullens, I had one ball of Play-Doh. Now I've got like 1,000. This is going to weigh more. Some of you said, no. That was a big ball of Play-Doh. These are very tiny. This is going to weigh less. Not many of us, now we say it weighs the same. Not many of us said it weighs the same, but think about it. Could I take all those teeny tiny little balls of Play-Doh and put them all back together to make that whole ball of Play-Doh again? Yes. So I didn't gain any Play-Doh. I didn't lose any Play-Doh. The parts make up the whole. I'm going to imagine Legos is coming up here soon. Yep. Then we took some Legos and we weighed all the little pieces of Legos. And I said, build me something. And so someone in here built like a quick building out of Legos. And I weighed the building. And again, we still have people saying, well, wait a minute. That building is just one thing. That was a whole bunch of pieces of Legos. All the pieces are going to weigh more. Some people said, no. Those are little pieces. That's a bigger piece. The building will weigh more. And then some of us finally started getting it. Wait a minute. That's the exact same pieces. They're just building something. It's going to weigh the same. And all of a sudden, the misconceptions about parts of the whole started to go away. And as I'm talking about this now, most of you are looking at me like, yeah, Mr. Bullens, we remember this lesson. We remember parts of the whole. This is really not that hard to get into. It's not. It is tricky because they will put, there is a 4-pound rope that someone cuts into 4 pieces. How much do the pieces weigh? And it's tempting to put 1. Because they do weigh 1 apiece, don't they? And it's tempting, but they're saying how much do the pieces weigh altogether? Well, it would be 4. So don't let them trick you with those kinds of questions. I'm not going to go over that or that. And we will move on from that. So parts of the whole, good? So As we move into a completely different topic, and the topic is heat exchange. I remember this. I think I've done this lesson more than once. As you all know, Mr. Bullens is not very fond of being out of school for any reason, especially snow. I appreciate the fact that you get to stay home, but we've all seen it this year, right?
Yeah.
Oh, we're going to be out for one day for snow. No, it was end up like... Yeah, it ends up being a week, and then we have to make things up, and I don't like that. If it wants to snow all day Friday, and we get out early, and we go home, and it counts as a day, and then it melts Sunday night, fantastic. You enjoy all your sledding, all that you want to, but I hate it when we miss too much school. And so we have this, there's always angry Mr. Bullens looking out his front door. That is a pretty accurate picture, too. That's a little scary, how accurate that is. I've got my khaki pants on, my button-up shirt, staring out the door angrily because I should be at school teaching. Conduction, convection, radiation. Would I be shocked if we saw this picture show up on the test? No, I would not. That showed up on the SchoolNet test. The people that wrote the SchoolNet questions are the same people that write the questions for the EOGs. This is a fantastic example. And I do like the fact that they have the hands above the fire for convection. Because fire doesn't always mean radiation. Does it mean radiation most of the time? But you need to read the question very carefully, because if it's sparks rising above the fire, then you have convection. Conduction, I think, is the easiest. Anytime you touch something and touching is going on and there's heat being transferred, that's a pretty easy one. Radiation, there is another example of radiation that I would be blown away, Nigel, if it wasn't on the EOG. What's the big example, Jordan, of radiation? The sun. I mean, good gracious, that fits right in with the water cycle. So if they don't put that, I will be shocked.
It's either the sun or fire.
Are there others? Yes. The lizard in the tank getting warmed by the light bulb, of course. They're going to put fire or sun on there. That's just their two go-tos. So again, what is heat? Heat is a form of energy that can be transferred between two objects that have different temperatures. Now again, this gets a little tricky, Kaylee, because people always think it's hot and cold. Not necessarily. It could be warm and cold. It could be cool and freezing. If I put a piece of ice on top of a piece of dry ice, it sounds weird, but there's actually heat being transferred. No. But Mr. Bullens, the ice is cold. I know, but it's warmer than the dry ice. So that's, unless we start getting to things like absolute zero, which you probably won't even talk about until college, and that's if you get into some crazy physics classes, it's always going to be some sort of heat exchange. How does heat move? Heat moves in a very specific way. If you don't remember the answer to that, it's at the bottom of this slide that's on the board. Heat moves in a very specific way, Gabby. From the hotter or warmer object to the colder object. Remember, it's very easy for me to say when I'm holding the ice in my hand, boy, oh boy, this ice is making my hand cold because the cold is going into my hand. That's not what's happening. Yes, the ice is making your hand cold because the heat is leaving your hand and going to the ice. Yes, sir.
What if two things are hot?
If they're the same temperature, there is no transfer of heat. If you've got something that's 1,000 degrees and something that's 900 degrees, it will transfer heat from the 1,000 degree object to the 900 degree object. Because it's technically cooler than the other object. Yes? Conduction, the passing of heat through touch. Give me some examples of conduction you think might be on the test.
You have another rod sitting inside of the fire and then you touch it.
Somebody touches a hot pan, a hot stove. Somebody touches something is going to be on there. What's another one? Burning your hand on the stove. What's another one? Yeah, you're stirring the spoon in your hot cup of coffee and the spoon burns your fingers. What's that? Holding ice. Cooking an egg. What about animals? There's one about animals that they love to do this. Animals love to do this. Dylan. Animals like to lay on a cool patch of dirt so the heat transfers from their body to the ground and they can cool off. That's a big one that we see kind of often. Again, There's all the ones that we just talked about. So again, I know there's a lot of people that are saying, I got to study, I got to study. Kids, we either have it at this point or we don't. This is just knocking the dust off of our brains this week. Can somebody learn something new this week? Yes. But I can't teach you a year's worth of stuff in 1 week. That's why we work hard all year. There's an angry Mr. Bullets again. Convection. Now, convection should make a whole lot more sense now that we've gone through weather. Because when we went through weather, we had sea breezes and land breezes, updrafts and downdrafts, and that really kind of solidified convection. What is convection? How does heat move through convection, Rachel? It moves through a liquid or a gas, and we usually have hot air or hot water rising and cold air or cold water sinking. Thumbs up if you remember that fun experiment that we did with the red and the blue water, watching the convection cell inside the jars. It was a lot of fun. We loved doing that. We had a good time. This is your convection, hot rising, cold sinking, and you have that circular motion. We see that with sea breezes and land breezes. We see that as wind is moving around. We see that in the pool in the summertime. Boiling an egg, movement of thermal energy around the earth. We learned about that. Boiling water. And that brings us to radiation. And we've already said this. I'm going to move through this one pretty quickly. Fire, sitting beside a fire, the sun warming the earth are the two big examples of radiation. Right? That's the two big examples. Hopefully I'll be sitting beside a fire sometime soon when school's out and enjoying some camping, which will be very nice. All right. Conductors. Conductors are things that heat moves through very easily. What is the one thing that heat moves through very easily? And we make a lot of different things out of it. Elle? Metal is probably the big one, right? We make our pots and pans out of metal. We have metal is also a good conductor of electricity. Things move through it very easily. And we want that to happen. Again, copper is very good. What's the opposite of a conductor? Something that heat does not move through so easily, Miriam. An insulator. I'd imagine that's probably here pretty soon. An insulator. Heat does not move through them very easily. If I'm going to be stirring like all day long inside of a hot pot of soup, what type of spoon would I want to use so that it does not burn my hand, Cora? Wooden spoon, plastic spoon, rubber spoon would work. Those are all very good. So, as far as heat exchange goes, are you guys feeling pretty good about that?
Yes, sir.
All right, I'm going to pause the video here. I guess just for Hunter's sake, whoever else is at home watching this, got to smash the like button, click the bell for notifications. Anything else, make sure to subscribe. Get me to 102. A gift card giveaway. If I reach 100 subscribers, I'll give every student a gummy bear today.